So in this video, we're going to be talking about something called index numbers. As usual, if you find these videos helpful, please like and subscribe and share them with your classmates. And if you have any suggestions for further videos, just leave a comment down below. Okay, so very often in economics, you'll have a set of data that are laid out over time, right? So, for example, you might have a list of prices or quantities for a series of years, okay? And we'll do some examples later, and you'll see what I mean. And you might want to answer the question, by how many percentage points did this quantity increase or decrease from one year to the next? And it might not be immediately obvious by looking at the data, just by looking at the numbers, right? So you want to construct maybe I guess we could call it an easier set of data to work with, and that's where index numbers come in. Okay, so before doing an example, I'm just going to write down the formula for an index number. And it won't be immediately obvious what the terms mean, but fear not, I will explain in a couple seconds. Okay, so an index number is equal to the value in a given period divided by the value in something called the base period, all multiplied by 100. Okay, now technically, okay, value is not exactly the right word. I should have written absolute value, okay, to be a little bit more precise, but I think that might make things sound or seem more complicated than they really have to be. Okay, so yeah, I think we'll just I like to just stick to the simple term value for now. Okay, so let's give an example. So let's say you have a pizzeria, okay, that's producing some quantity of pizzas every year. Okay, and we have, as economists who want to study this business, we have a list of quantities of pizzas from the years 2010 to 2015. Okay, so let's make a little data table. So we have the year in one column. We have the number of pizzas in the next column. And then we're going to make a column for the index number, okay? And all of this is about to be demystified for you. Okay, so like I said, we have data from 2010 to 2015, so let's just list the years. Okay. Oops. Okay. So, in the year 2010, this particular pizzeria produced 200 pizzas. In 2011, it produced 210 pizzas. In the year 2012, it produced 225. In 2013, it produced 215, 250, and finally 220. Okay, so, I mean, there are a few things that are obvious by looking at these data. The first one is that pizza consumption definitely increased from 2010 to 2015. In fact, in every year, starting in 2011, the pizzeria produced more pizzas than it did in 2010. It's also clear that there are some fluctuations, right? So between 2010 and 2011, the number of pizzas increased, and then it increased again in 2012, before decreasing a bit in 2013, then experiencing a dramatic increase in 2014, and then an almost equally dramatic decrease in 2015, okay? But it might not be obvious, except to those people who are pretty good at mental math, by exactly what percentage of the initial quantity of pizzas the quantity of pizzas increased by in future years. Okay, and that's where index numbers come in. So the first thing we have to do to construct an index number is choose what I've called up here a base period. Okay, so in our case, really what we want to do is determine a base year. Now the base year is just another way of saying the starting year, okay? So in our case, just for simplicity's sake, at first, let's just choose 2010. Okay, 2010 is our base year. Now you might notice just by looking at the formula that the index number in the base year is always 100 because, well, in our case, let's use 2010. What is the value or the number of pizzas, right, in our base year? Well, it's 200, right? What is the value in the base year? Well, I mean, 2010 is the base year, so it's just 200. So you're dividing 200 by 200, and you just get 1. And then when you multiply that by 100, you simply get 100. So this is true for all base years, okay? The index number in the base year is always 100, okay? So when we talk about the value in the given period and the value in the base year, what we're talking about is the quantity in which we are interested. In this case, we're talking about pizzas. We're interested in the quantity of pizzas, the number of pizzas. So the value is simply this column here, number of pizzas, right? Okay, so what would our index number be in 2011? Well, in 2011, the value in the given period, or the number of pizzas produced in 2011, is just 210, right? So we divide 210 by the number in the base year, which is still 200, and we multiply that number by 100, and we obtain 105. Okay, so our index number in 2011 is 105. And then we do the same thing for all subsequent columns, okay? In 2012, we divide 225 by 200. All right, 225 is the quantity in the given period. 225 pizzas produced in 2012. We're dividing it by 200 because 200 is the quantity in the base year, and we're multiplying by 100 to get 112.5, okay? And now I'm just going to write out the values for the 3 final years in our data set without doing the calculations, but the form of these calculations is the exact same. Okay, so we now have our list of index numbers. Okay, so what have we gained by doing this? Well, we basically have gained a very, very obvious sense of the percentage increase in quantity of pizzas from 2010 to any other year, okay? So how have we done that? Well, let's start with the fact that the index number in 2010 is always 100, right? Now, when we talk about percentage, we're really talking about a fraction out of 100, right? So if I say 15%, another way of expressing 15%, right? 15% is by just saying 15 out of 100, right? So now if I ask the question, what is 15% higher than the number 100? Okay, so what is 15% higher than 100? It's just 115. You're taking 15% of 100, which is just 15, and then you're adding it to 100. 100 plus 15 is 115. So what is the point of saying all of this? Well, let's take the number of pizzas produced in 2011, okay, which is 105. By what percentage did the number of pizzas in 2011 increase from 2010? Well, very easy. It increased by 5%, right? Because this little 5 right at the end is just obtained by doing 100 plus 5, right? Or 100 plus 5% of 100. Okay, same thing for 2012. By how much did pizza production increase from 2010 to 2012? By 12.5%. Okay, in 2013, the answer is by 7.5%. In 2014, it's by 25%, and in 2015, it's by 10%. Okay, so because the index number in the base year is always 100, okay, and because it's very easy to see visually, okay, by how many percentage points the number 100 has increased by, right? If you just have the number that says 100 and something, that something will be the percent increase, then index numbers become very useful for determining percentage increase. Okay, now I want to just flag a few possible pitfalls here, okay? Mistakes that you really should be careful not to make. If I ask you, by what percentage, okay, has pizza production increased from 2011 to 2012, okay? So in 2011, our index number is 105, and in 2012, our index number is 112.5. Okay, so by what percentage did the number of pizzas increase from 2011 to 2012? A lot of students would be very tempted to simply do 112.5 minus 105. They would get 7.5, and they would conclude, okay, 7.5%, right? Wrong. This is wrong. Why? The index number has increased by 7.5. That is true. But this 7.5 is not 7.5% of 105. Okay? 105 in this case is the starting number. And then our finishing number, so to speak, is 112.5. So there's an increase in 7.5. But 7.5 is not 7.5% of 105. 7.5 is 7.5% of 100, right? In other words, this is all a complicated or a convoluted or a long-winded way of saying that the base year really, really matters, okay? All these index numbers tell us is by what percentage pizza production has increased from the base year, not from any other year. So if we wanted to get the percentage increase from 2011 to 2012, we would have to make 2011 our base year, okay? And we'll do that right now just to show you what I mean by this, okay? So let's make 2011 the base year. So now we know that the index number, okay, in 2011 is going to be 100 because the base number, the index number in the base year is always 100, okay? So now, how do we find the index number for 2012? Well, we follow the formula. 112, not 112, sorry. Because now we're going back to initial quantities of pizzas, right? So, 225 divided by 210, right? Times 100, which is equal to, give me one sec here, divided by 210 times 100, which is equal to approximately 107, right? Now we can conclude, okay, the percentage increase is actually 7%. right? Before we had gotten 7.5%. It's actually 7%. And now we can do the same thing for 2013 if we want to get the percentage increase from 2011 to 2013, right? We can take the quantity of pizzas in 2013, in 2013, which would be 215, right? Divide that by our base number, which is 210, and multiply that by 100, which would give us approximately 102. So that means that the percentage increase from 2011 to 2013 is 2%. Now, I'm going to flag one more possible pitfall, okay? Let's take 2000 and let's see here. Let's take 2012 as our base here. All right? Let's take 2012 as our base here. So in 2012, our index number will be 100%, or sorry, not 100%, but 100. Right? And in 2013, we can calculate our base number by taking 215, dividing it by 225, and multiplying this by 100, which would give us approximately, rounding up here, 96. Okay, so this is interesting. So we have our first example of an index number that's actually lower than 100, okay? But the same principle applies here. How do we get from 100 to 96? Well, we just do simply minus 4. So here we conclude that the percentage has decreased by 4%. There was a 4% decrease. Now, can we therefore conclude that in 2012, there were 4% more pizzas than in 2013? No, because there was an increase of 10 pizzas, right? If we're going backwards in time now, there's an increase in 10 pizzas, but those 10 pizzas do not represent 4% of 215. What do we have to do? Well, if you said we have to make 2013 the base here, then you are right. All right? So the conclusion is simply this. Index numbers are useful, okay, for finding the percentage increase or the percentage decrease from the base year, okay? If you've chosen 2010 as your base year, you cannot say anything, okay, according to the index numbers, about percentage increase from any other year except 2010, or percentage decrease from any other year except 2010, okay? Once you've chosen the base year, you're stuck with it. If you want to find the percentage increase or decrease starting from another year, you must first make that year the base year, if you want to use index numbers, right? Now, of course, you don't have to actually construct index numbers if you don't want to, right? If you want to get the percentage, I mean, this lesson is on index numbers, but I don't want to give the false impression that index numbers would be the only way of doing this, right? So just, for the sake of completeness, if you're watching this video just to understand index numbers, you can basically stop the video now. But I mean, let's say I want to know, okay, pizza production has increased clearly. The number of pizzas in 2014 is clearly higher than the number of pizzas in 2015, okay? Well, by what percentage is it higher? Well, we know that we could see here the number of pizzas has increased by 30. Now, the only question is, what percentage of 220 is 30? Well, then you can just use ordinary, your ordinary percentage calculation, right? Sorry, I think this might be a little light. Right, okay. Plus 30. Well, 30 divided by 220 times 100, which is approximately 14%, well, 250 is therefore 14% higher than 220. Okay, so index numbers is not meant to make your knowledge of percentages just go out the door, okay? All it's meant to do is make it visually obvious, okay, by what percentage a quantity has increased or decreased from the base year. Now, why might this be useful? Okay, final point of this video. Why might this be useful? Well, it's useful in the case of something like the CPI, the Consumer Price Index, okay? This is probably not something you need to know for this course in particular. Well, actually, if you're taking macro, this might be quite useful. So the CPI stands for Consumer Price Index, okay, and this is an index number, okay? The CPI is an index number. This I stands for index, which is meant to give economists and consumers and policymakers, I suppose, an idea of how much the average consumer's basket of goods has increased from a base year. All right. So your basket of goods will include staples like food, and to be quite honest, I don't know what else it includes. It might include things like diapers and things like that. Although I'm not exactly sure. But essentially, the average consumer basket in this case is meant to be a representation of what your average consumer has to buy in a given a week or month, depending how you're measuring it. All right. So if we choose 1990 as our base year, right, then the CPI in 1990 would be 100, right? Now let's say that in the year 2023, the CPI is 220. Well, then we can very, very easily see that consumer prices have increased by 120% from 1990, right? We do 220 minus 100, that gives us 120, right? 120%. So that's an example of where index numbers might be useful. Okay, so as usual, as I said at the beginning, like and subscribe if you find these videos useful. Leave a comment for further suggestions, and I will see you in the next video.